Now the fifth one. In right triangle ABC, right angle at B, and if angle A is theta, given sec theta is equal to 13 upon 12. Find all the other trigonometric ratios. Sec theta is equal to 13 upon 12. What is sec theta? 1 upon cos theta. That is hypotenuse upon adjacent side. Hypotenuse is AC divided by AB. Therefore, if AC is equal to 13K, then AB is equal to 12K for some K positive integer. Positive number, not the positive integer is also same. In right triangle ABC, right angle at B, we have AC square is equal to AB square plus BC square by Pythagoras theorem. That is 13K bracket square is equal to AB is 12K bracket square plus BC square. It is 169K square is equal to 144K square plus BC square. Therefore, BC square is equal to 25K square. That is 144K square. When it comes to the other side, we are having 169K square minus 144K square is equal to B square, where we get BC square is equal to 25K square. Therefore, BC is equal to 5K. Now we can find all the ratios by definition. BC is equal to 5K, AC is equal to 13K, AB is equal to 12K. When we have the values of all the sides of a right triangle, we can find the trigonometrical ratios as we defined earlier, as sine of theta is equal to opposite side upon hypotenuse. Here opposite to angle theta is BC. So sine theta is equal to BC upon hypotenuse AC. It is 5K upon 13K. This is 5 upon 13. Cos theta is equal to adjacent side AB upon hypotenuse AC. This is equal to 12K divided by 13K. This is 12 upon 13. Now tan theta. Tan theta is opposite side upon adjacent side. BC upon AB. This is 5K divided by 12K. This is 5 upon 12. And tan theta is sin theta upon cos theta. We have defined it as earlier. We can write directly as sin theta upon cos theta is 5 upon 13 divided by 12 upon 13. We get 5 upon 12 only. Then cosec theta is equal to 1 upon sin theta. This is equal to 13 upon 5. Sec theta is equal to 1 upon cos theta. This is equal to 13 upon 12. Cot theta is equal to 1 upon tan theta is equal to 12 upon 5. Now the sixth one. You can help yourself by making a chart where you can write the ratios of all the trigonometry so that it will be helpful. Now the sixth one. If angle A and angle B are acute angles such that cos A is equal to cos B, then show that angle A is equal to angle B. Let's consider two right triangles APQ and BRS. A, P, Q and B, R, S, where angle P is right angle, angle R is right angle. It is given that cos of A is equal to cos of B. In these two triangles, we have cos of A is equal to adjacent side, it is AP divided by hypotenuse, it is AQ, and cos B is equal to this angle B, and the side adjacent to this angle B is BR divided by hypotenuse BS. Because cos A is equal to cos B given, we write AP upon AQ is equal to BR upon BS, which implies, or we can write this ratio as AP upon BR is equal to AQ upon BS. This is equal to K for some positive number K. We have AP upon AQ is equal to BR upon BS given. This implies we can write this ratio as AP, take BR to this side, it becomes division because it is multiplication here. AP upon BR is equal to AQ upon BS. Now using Pythagoras theorem, PQ is equal to PQ in triangle APQ, PQ is equal to square root of AQ square minus AP square, and RS is equal to square root of BS square minus BR square. Directly I have written by Pythagoras theorem PQ square is equal to AQ square minus AP square. Therefore, PQ is equal to square root of AQ square minus AQ square. Similarly, in this triangle, RS square, we want RS. RS square is equal to square root of BS square minus BR square. RS square is equal to BS square minus BR square. Therefore, RS is equal to square root of BS square minus BR square. Now we will take the ratio of these two sides. So we have PQ upon RS. PQ upon RS is equal to square root of AQ square minus AP square divided by square root of BS square minus BR square. But from 1 we found that AQ is equal to KBS. This is equal to square root of K square BS square minus, and AP is equal to KBR. Therefore, AP square will be K square BR square. This divided by square root of BS square minus BR square. Now we observe that in these two terms, inside this square root sign, K square is common. So taking K square outside, we are left with BX square minus BR square whole divided by square root of BS square minus BR square. This is equal to K square into square root of K square into square root of BS square minus BR square divided by square root of BS square minus BR square. This is equal to square root of K square. This is K. Square root of BS square minus BR square and square root of BS square minus BR square. These two terms are in the numerator and the denominator, and they get cancelled. We are left with square root of K square, and its square root is K. Now we have AP upon BR is equal to AQ upon BS is equal to K. This is first equation. And PQ upon RS is equal to K. So from 1 and 2, equations 1 and 2, we have AP upon BR is equal to AQ upon BS is equal to PQ upon RS. Then by using theorem 6.4, or when the sides of the two triangles are in the same ratio, that is AP upon BR, PQ upon RS, AQ upon BS, then by that theorem you can conclude that triangle APQ is similar to triangle BRS. Therefore, corresponding angles are equal. Angle A is equal to angle B. This angle is equal to this angle. And similarly, this angle is also equal to this angle by the theorem. When the sides of two triangles are proportional, then the triangles are similar. When the triangles are similar, corresponding angles are equal. Therefore, angle A is equal to angle B. Now the question 7. These questions are same in state syllabus also. Don't think that this is the only syllabus, CBS syllabus I am solving. Exercise number may be different in state syllabus book. Then the 7th question. If cot theta is equal to 7 upon 8, evaluate 1 plus sin theta in one bracket, 1 minus sin theta in another bracket, 1 plus cos theta in one bracket, 1 minus cos theta in another bracket. Consider a right triangle ABC, right angle at B. and we'll say that this angle A is theta. It is given that cot of theta is equal to 7 upon 8. That is AB upon BC is equal to 7 upon 8. Cot of theta is adjacent side. The side adjacent to this angle theta is AB and the side opposite to this angle theta is BC. This is opposite side and AB is adjacent to this angle theta. Therefore, AB upon BC is equal to 7 upon 8. If AB is equal to 7K, then BC is equal to 8K for some positive number K. We have AC square is equal to, or AC directly we can find AC is equal to square root of AB square plus BC square by Pythagoras theorem. This is equal to square root of AB is 7K bracket square plus BC is 8K bracket square. This is equal to square root of 49K square plus 64K square. This is equal to square root of 113K square. This is equal to K root 113. When we find hypotenuse, then we can evaluate the required ratio. This is K root 113 and AB is 7K, BC is 8K. 1 plus sin theta into another bracket 1 minus sin theta divided by 1 plus cos theta into another bracket 1 minus cos theta. We have to evaluate this value. By substituting the values we have found and by given thing we can write this is equal to 1 minus sin square theta. Why? 1 minus cos square theta. Why? By the identity a plus b into a minus b is equal to a square minus b square. Here a is 1, b is sin theta. Therefore a square is 1 and b square is sin square theta. 1 plus cos theta into 1 minus cos theta. Applying the same identity, a plus b into a minus b is equal to a square minus b square. This is equal to 1 minus, what is sin theta? We will find sin theta is equal to opposite side 8k upon hypotenuse, k into root 113. This is equal to 8 upon root 113. Therefore, sin square theta is equal to square of 8 upon root 113 bracket square. This is equal to 8 square upon 113. That is 64 upon 113. Therefore, it is 64 upon 113. This divided by 1 minus. Similarly, we find cos theta and cos square theta as cos theta is 7k upon root 113k. Adjacent side is 7k. Therefore, similarly, we can find cos theta by finding like this. We find cos theta as 49 upon 113. So this is equal to 49 upon 113. By taking LCM, we can write 113 minus 64 divided by 113 whole divided by 113 minus 49 divided by 113. This we can further solve and get the values as 49 upon 64. Similarly, the second one. What is the second one? Well, we have to evaluate cot square theta. It is given that cot theta is 7 upon 8. Therefore, cot square theta is equal to 7 square upon 8 square. This is 49 upon 64.